Yeah, I'm going to change that.
Hello everyone, I'm Afshin Lorestani. Today I'm honored to present another research from Cosmomental, effect of T consciousness fields and the thermoluminescence phenomenon. Let's get start our journey together. In order to save time, I will use TL instead of thermoluminescent and TLD for thermoluminescent dosimeter and also TCF for T consciousness fields. As an overall view, the study explored the impact of three types of TCFs on the TL phenomenon using commercial GR200 TL chips. These chips were well prepared and irradiated multiple times with and without TCFs applied before reading. Results showed a reduction in chip direct responses after TCF treatments individually and a population of 15 chips. The entropy of TL emission was calculated, showing changes before and after TCF treatments with an overall decrease in the population. Overall, the study demonstrated the experimental effect of TCF on the TL phenomenon. So that was an overall explanation about what we have done. And so let's go to detail. So as introduction, what is TLD? TLD are used to measure gamma, X-ray, and beta radiation exposures. They can be worn as rings or body badges. They contain small chips of lithium fluoride which absorb ionizing radiation energy and displace electrons from the ground state. And you can see here, so that's a sample. Here you can see these are samples. Nuclear detectors and dosimeters are used to detect and quantify the effects of ionizing radiation on matter with TLD as a tool, specifically used in the fields of medical, agriculture, industry. Nuclear science and technology are employed to gain insight to TCFs at the atomic level. TLDs which passively measure radiation dose which rise the TLD phenomenon and are suitable for exploring the microscopic effects of TCFs. Okay, mechanism of TL phenomenon. TLD with their crystal structure and energy levels allow for effective trapping of electrons and holes. When exposed to radiation, electrons are released from the valence band and trapped in energy levels within forbidden gaps of the crystal, while empty places that are called holes are also trapped. Heating a TLD causes electrons to be released from the traps and emit optical photons, which are detected as TL light. TL light intensity is measured in TLD leader and glow curve is plotted. So here you can see these are the TLD chips and this is the TLD reader and it's a plot, glow curve plot. In the 1980s, Mohammad Ali Taheri introduced T consciousness, a non-material, non-energetic element believed to coexist with matter and energy in the universe. TCFs, as we explained, cannot be directly measured, but their effects can be studied through reproducible experiments, as Mushin explained for cells. Research on TCFs has grown recently with the studies exploring the effects on various materials and living organisms. The effects include changes in the magnetic properties of metal, half-life isotope in water, mechanical properties in steel, pH, changes in water and responses of cancer cells, plants and animals to stress and disease. Okay. In this experiment, we used 16 GR200 chips. These are the chips, as they call TLD chips. Known for their sensitivity to various radiation, the chips were prepared by annealing to raise unwanted TL light and preheating to eliminate low temperature and unstable peaks in glow curve before radiation with a beta irradiator containing 90 SR. The chips were rotated to ensure uniform irradiation. TL responses and glow curves were measured before and after TCF treatment with a single chip and population of 15 chips. A single chip was emptied and read before irradiation. Then after 30 radiation returns, its response and glow curve were measured and plotted. Once again, it was prepared for the exact dose equivalent of irradiation, and TCFs were applied 1 minute before the irradiation. Finally, responses and glow curves were measured and plotted. For the other batch, it's a batch for 15 chips. After preparation, were irradiated with dose equivalent of 3.32 ms3 in the irradiator. Then the reader recorded the responses and glow curves before influence of TCFs. In the same way, the previous steps were repeated while TCFs were applied along with irradiation. 3 types of TCFs were applied to the samples, similar to the other experiment that Afshin explained. The experiment was overseen by Mohammad Ali Taheri, the founder of TCF theory, who aims to conduct reproducible experiments related to TCFs. In this study, TCF 1, 2, and 3 were applied to the samples with untreated samples as control. TCF 1 optimized the subject under study based on ecosystem rules, and TCF 2 records a specific change request. TCF 3 aims to eliminate negative factors affecting sample behavior to adapt to optimal conditions. The experiment showed that, so this is a result on a single chip. The experiment showed that, so let's just start here before we're gonna go deeper. So it can be stated that before TCF treatment, control responses showed minimal variation. In contrast, TCF treated samples exhibited lower average value, as you can see here. Glow curves analysis revealed distinct patterns between control and TCF treated samples. The TCF treated samples showed significant deviations. Repeated TCF applications seem to enhance changes, although the third treatment showed no noticeable changes. As you can see here, these are the number from the TLD reader, and here, as you can see, the controls and TCF. As you can see the trends here, and you can compare them to each other, and you can see changes here. And even the glow curve here is here for control, and here for TCF, and you can see the difference in the patterns. And here is a compare of the control A to TCF A, and you can specifically see the differences here. The experiment showed that the control samples maintain consistent responses, while TCF's treated samples demonstrate reduced TL responses, with a difference increasing to 11.7% after 3 consecutive TCF treatments. Results from glow curve effects of TCF treatment on a single chip indicate significant alteration in TL behavior due to TCF's application compared to the control sample. Further research is recommended to explore the impact of repeated TCF application on sample behavior. These are results for only on one chip, but here we have a result on population of 15 chips. Here, as you can see in this table, Q represents the direct responses of samples from last year. QI, the responses the day before TCF treatment, and QF is the responses 2 hours after applying TCFs. As you can see, QO value allows us to understand the responses during various periods of time, and QI, as you can be observed, different responses of the sample were obtained after the same irradiation, which was related to the slight differences in the material of chips, as you can see. Sorry, these are not the same, but because of the slight changes in the material of each chip. And as you can compare the QI to QO, you can see after passing a year, QI, the response reading from the is very smaller than QO. Similarly, this reduction appeared under the influence of TCF, as QF values were smaller than QI. As you can see here, it is smaller than QI. Here in this slide and the next slide demonstrates significant alteration in glow curve of 15 chips pre-TCF treatment, colored in red, and post-TCF treatment colored in green, reflecting their diverse structures. The responses can be categorized in three different scenarios as follows. First scenario, TL intensity change without changing the peak displacement for chips E6, C10, E3, E12, E6, E10, D8. Second scenario, the number of peaks and their displacement remain constant for chips D11, E11, and E7. And last scenario, the third one, reducing the number of peaks for B6, C4, D10, and F2. In the first case, the curve is a slide, except E9 chip, there was a decrease in the number of trapped electrons under TCF treatment. However, in the second case, the treatment reduced the number of electrons in existing trap and redistribute them to new levels. Lastly, for the third scenario, indicates a decrease in the number of electrons in a specific trap. Since there were no physical intervention, such as electromagnetic fields, any significant change in the response or characteristic of the glow curve of the sample may attribute it to TCF treatment. Each peak in glow curve, these peaks, site represent a site or they call it energy state for trapping electrons and implies the probability distribution of TL light emission. Moreover, the location of the peak in the glow curve shows that temperature required, you see here, is based on temperature. Temperature required for releasing electrons and combining them with holes. The investigation extended to address the impact of TCF on the population of 15 chips, each varying in lifetime and radiation exposure. Analysis of TL responses revealed a reduction in TL value over time, both before and after TCF treatments, indicating a consistent trend of decreasing responses. Normalized changes demonstrate a significant increase in TL response reduction under TCF treatment, emphasizing the exclusive influence of TCF on chip behaviors. These findings suggest that observed results may attribute to TCF, so no other treatments were administered during the study period. In thermodynamics, entropy is a measure of disorder in a system which increase over time according to the second law. From the statistical mechanics perspective, entropy measures the energy distribution in a system's macrostates. In communication, that's one. The third one, in communication theory, entropy reflects the uncertainty of an information source. It assumes that before receiving some information, the system is in a physical state with the maximum uncertainty or entropy. At the same time, after that, it can reduce its value. Taheri theorists consider TCF as information sources, allowing entropy to be determined based on communication theory. Moreover, based on the principle of conservation of matter-energy consciousness introduced by Taheri, it can be assumed that there is a possibility of exchanging energy between TCF and the system under treatment. Consequently, the concept of statistical mechanics are also helpful in this case. Here in table 3, gives the entropy value of the chip in the population with a standard deviation. In this table, SO is entropy in the last year, SI is related to before TCF treatment, and SF represented after TCF. As it is predictable, according to the second law of thermodynamics, the entropy values for last year's population increased, as you can see here, based on the second law of thermodynamics, entropy increased. Whereas under the influence of TCF treatment, there was a reduction for 8 chips, as you can see, for 8 chips, based on the theory is supposed to be increased, but they decrease, as you can see. Moreover, the total entropy of all those 15 chips also decreased. It seems that the influence of the TCF is associated with a reduction in entropy of this study population. In the subsequent analysis on this slide, we investigate the relationship between entropy and time asymmetry in the result obtained for the chips. Traditional macroscopic thermodynamics in closed system predicts an increase in entropy and disorder over time, aligning with time asymmetry. However, the macroscopic perspective suggests that internal alteration within the system can alter the directional flow of time. But here, the observed reduction in entropy value for chip population post-TCF treatment, here as you can see, contradicts the time asymmetry concept, indicating a departure from the expected trend, as you can see here in the trend. This finding resonates with prior research on water, where reduced entropy was also observed. Notably, while previous studies utilized thermodynamics calculation and measure information exchange, this experiment marks the first instance of such an observation at macroscopic level. The mechanism behind the effect of TCF on materials and systems remains to be discovered, hindering precise interpretation of their function. However, based on data from this study, two potential reasons for the reduced electric charge of the chip on the TCF treatment are proposed. The first one, generation of fewer ionization electrons after irradiation, or decrease in the number of electrons trapped in impurity sites. Considering the assumption in TCF theory that these fields do not affect the inherent characteristic of the system, the first reason is deemed unlikely, as the amount of ionization energy required for releasing electrons by irradiation is a material characteristic that are unaffected by TCFs. Therefore, it is suggested that TCF treatment may reduce the trapped electrons in impurity size, leading to decreased TL intensity and responses at this one. It is known that changes in glow curves can occur due to various factors such as the passage of time, external electromagnetic fields, or over-limit irradiation. However, as none of these factors were presented before and after TCF treatment in this experiment, the observed change in glow curves may be attributed to TCF treatment, indicating alteration in physical parameters involved in TL emission. Overall, the result suggests that TCF may change the structure of the chip and alter the functions of the atomic energy level. This may indicate a transfer of energy from TCF to the chips, potentially involving the conversion of T consciousness into energy. Further measurements will be conducted to test reproducibility and investigate the stability of TCF treatment alongside continued research into this topic. To sum up, in this study, the impact of TCF on TL phenomenon using commercial GR200 TL chip was explored, and these are the key findings: that TCF may induce electron displacement in atomic energy level, exhibiting distinct behavior compared to the control. TCF treatment chip population more than half experienced a reduction in entropy, leading to an overall decrease in total entropy. Contrary to the communication theory, which suggests that increased information reduces entropy, TCF treatment explore variable entropy changes depending on system requirement. In the last one, the observation of time direction change at microscopic level to the TL phenomenon for TCF samples contradicts the time asymmetry hypothesis. A special thanks to our research team, and if you guys are interested to know more information about our scientific experiments, or you would like to collaborate in any kind of experiments in the field of T consciousness, please contact Cosmonitor through email, website, or by scanning this barcode shown here.
Thank you.
Please visit, of course.
Any questions for Afshin? Okay, well, thank you.
Of course. It's my pleasure.
Next we have Charles. And Charles comes from Colorado.